Coming up next on the IP Talk stage, M.Y. Park from Samsung, presenting Samsung Library and IP offerings.
Okay, good morning, everyone. I'd like to introduce Samsung Foundry's library and IP preparations. Okay, first, before start IP offering, I'd like to introduce that our history of the technology, as well as that manufacturing capability providing to our foundry customer. First of all, our strength is that the leading edge process. Of course, we are working together with many collaborations, the IBM, Global Foundry, and also that the ISDA collaboration. That is one of the strong point of the leading edge process. And the other one is, of course, the Samsung is well-known memory provider, so we leverage that memory technology. And the second one is that manufacturing excellence, which is that from the 90 nanometer we use that 300 millimeter wafer fabrication. We have a S1 line in Kihyung. The other one is the S2 line in Texas, Austin. The other one is that this is the third bullet is the main topic, which is that turnkey solutions. We have a ASIC design center in local, and also we provide that silicon validated libraries and IPs, and also we have advanced package solution. So for the customer's perspective, we have a turnkey solution we can provide, not only just process but also all the libraries. Okay, so to support the customer, important thing is the design enablement, right? There is a four main key element. First one is the PDK. So PDK starting from the SPICE till PNR tech file whole coverage we support. Second one is that nowadays deep submicron, one of the important things is the DFM, right? So we have a DFM kit provide. Not only providing the DFM kit, but also we provide that all the DFM solution, DFM services, because nowadays some of the customer doesn't have proper software, which we prepare that the solutions, right? Then we need to provide the DFM services for our customer. We do those services too, and the other one is technology enabling. We do that double patterning and the TSV kind of advanced technology preparing together with our customer. And the last one is the libraries. Silicon proven standard cell, I/O, memories, and high-speed interface IP like USB SerDes, which I'm gonna talking later, and also that the mixed signal IPs, ADC, DAC, all those kind of things. Okay, so the PDK, one of the basic element to the enabling then cooperate with our customer is that mainly, as you can see, that we supported all major EDA vendor software environment, from the schematic, layout, modeling, and the physical verification, and also that the DFM kits as well. So this is basically we all the major EDA vendors the software environment, and can be doable for the all major foundry customers. Okay, I'd like to emphasize this slide that the most the main reason is that basically Samsung's perspective, right? The IP, all the IPs, basically all the IP providers. Some of the IPs we develop by ourselves. Some of the IPs we licensing from the other third-party the vendor like Synopsys and whatever, right? Then for the customer's view, they don't see that the third-party IP vendors. Samsung take all the ownership and all the responsibility of the IPs. So the customer's perspective, all the IPs coming from Samsung, not from the other third-party IP vendors or that other strange guys. So the IP comes from the Samsung is that basically Samsung guarantee that the functions, quality, and everything. So that is one of the strong points of the Samsung IP support. Okay, library solution point of view. So basically we have a common platform backbone IPs. basically it comes from the, we co-work with IBM and also that the ARM and the Global Foundry is kind of common platform libraries. There is a standard cell libraries like 9-track, 12-track, basic library sets. And also we provide all the, memory compiler, high density, high speed, single port, dual port, and the general purpose, library sets. This is kind of the basic sets of libraries. On top of this, we provided enhanced library sets, which including like pulse-based flip-flop to make it faster. Normally, this kind of pulse-based flip-flop we are using for the ARM core hardening. So this kind of additional specific IPs for the specific applications. We prepare that the pulse-based flip-flops and RTC library sets, even higher voltage operation like 1.8 volt, 2.5 volt, RTC libraries, and also ultra low power memories, and also that 3.3 volt true interface with a 5 volt tolerant. We support that. So basically, what I want to talk in here is that basically we support that the backbone library. On top of that, customer-specific, application-specific libraries we support. In here, I just want to show that the 28, 20, and actually 14 is coming. The lineups here. So in the 28 nanometer, LPP is a low power process. Here we have high density, 9-track and the high speed 12-track libraries we have. And the memory point of view, we have high density, high speed, and on top of this is on top of library, really ultra high speed because of the basic kit of the common platform libraries doesn't have that high speed memory in the 2-port register file. So we develop it specifically for the high speed the applications. And also in here, the blue color here is that basically that basic library set is mainly 1.8 volt true interface. But we want that the 3.3 volt true interface with a 5 volt tolerant, we develop it. And eFuse, and also OTP. So of course, this library says we license from the third party, and then we verify by ourselves. So customer's perspective, customer can use it as it is. Sorry? I think I can tell. This is a kilopath. Yeah. Okay, that is a basic library sets I just talked about. Nowadays SoC, right? There's lots of IPs, required for the SoC design. So of course we have a master license with ARM. So all the processor which has ARM, Samsung can provide to our customer. Okay, so all the ARM processors we can provide. And system IP perspective, interconnect IPs, memory controllers. Some of them we develop by ourselves. Some of them we license from our third parties. And high-speed interface IP. This is mainly for the hard macro cells. Some of them, few partners here. So the beauty of this IP is that we responsible. Samsung responsible these IPs. We do the silicon verify and we provide to our customer. That's the beauty. And this one, I already mentioned that. Oh, here. Mixed signal IPs. We have let's say about 200 people, designing the mixed signal IPs. So basic IPs we just prepare. And then if the customer asking, customize and all new develop, we also provide that, IP design service too. Okay, so nowadays, all especially for the mobile device and the network device need that ARM processors. So if you can see here, 32 nanometer, we already, completed all the IP development. This is kind of our basic lineup. A15 we achieved about 1.3 gig. And the 20 nanometer is complete. The A15, 1.3 gig, we already achieved it. 20 nanometer LP process is under development, so our targeting is 2.1 gigahertz. And the Cortex A7, normally, big little, combinations. So Cortex A7's target speed is about 1 gigahertz in 20 nanometer LP process. Actually, that's it. Thank you very much.